Hello everyone. So welcome to the online class on problem solving using C. So in this we are going to learn about structures. So in C program, a structure is a user defined data type that allows us to combine different types of data into a single unit. Unlike arrays, which stores only similar data type, but structures can store heterogeneous data, which means different types of like integers, characters, floats, and together. For example, we can take store multiple values. We can store those multiple values such as id, name, salary, and etc. Instead of creating separate variables for each, we group them into a single structure. So a structure helps in organizing related data efficiently under one name. Each individual item inside the structure is called a member. How to declare a structure? To create a structure in C, we use the keyword struct. This defines a new data type. So the syntax includes the keyword struct, a structure name also called as tag, curly braces containing member variables. Here we have an important point that always end the structure with semicolon. Example, here employee is the structure name and ID, name and salary are its members. These members represent different attributes of an employee. So this step only defines the structure, does not allocate memory at. In the given example, we can see struct is the keyword, employee is a tag or structure name, and ID, name, salary are the members or fields of structure. How to declare variable in structure? So after defining a structure, we need to create variables to use it. So these variables are called structure variables. There are two ways to declare them: separate declaration, that is inside the main function, and declaration using the structure. So we define the structure first and later we'll declare the variables like E1, E2. So in this method, this is flexible because we can create variables whenever needed. In the next method, we declare variables immediately after defining the structure. So this saves code but is less flexible. So here we are having some key concept. So use the first method when the number of variables is not fixed. Use the second method when the number is fixed. How to initialize? Structure variable can also be initialized at compile time. See here, struct patient, open curly braces, float, height, int weight, int age, close the curly braces, semicolon. So struct patient P1 equals to, within the curly braces, 180.75, 73.23. So this is initialization. Or struct patient P1 semicolon. So we can initialize the values with using P1 dot height equals to 180.75. This is initialization of each member separately. P1 dot weight equals to 73. P1 dot age equals to 23. So initialization means assigning values to the structure members. So in this we can use the two ways: compile time initialization, runtime, that is manual initialization. In compile time initialization, we can assign values when declaring the variable name. Example, values are assigned in order to height, weight, and age. And the second one, runtime, or that is manual initialization. We assign values individually using dot operator. For example, we access each member like p1 dot height, comma p2 dot weight, comma p1 dot age. Here the important idea is initialization helps us give meaningful starting values to structure members. Next, accessing structure members. So, accessing structures or accessing members of structures. Here, there are two ways to access structure members: by dot operator or member, by structure pointer operator or arrow operator. So, when the variable is normal type, then go for struct to member operator. When the variable pointer is type, then go for pointer to member operator. Any member of a structure can be accessed as structure variable name dot member name. Example, struct book within the curly braces, char name, char author in pages. So the first one, dot operator used when working with a normal structure variable, that is v1 dot name, v1 dot author, etc. The next one, the arrow operator used when working with struct pointers, that is normal variable use dot or pointer variable use arrow. So this allows us to create, read or modify the values stored inside the structure. In the example, we can see, so ID, name, salary are the members and inside the main function. So inside the main function, we declare a structure variable E. We take input from the user using scanf. We display the values using printf. We all know that printf is a statement which is used to print the given statement, and scanf which is used to input or scan or access the values. Okay, here we are going to use format specifiers in scanf, but so which represents which type of data it is. Suppose if you are using percentile d, which is having the integer data type, percentile s char data type, and percentile f float data type, and we are using n for integer and float inputs and no n needed for string arrays. You can see the example. So access members using dot operators. So this example shows how structures are used in real programs to store and display grouped data. So this program asks the user to enter employee details, that is ID, name, salary. After entering values, the program prints them back. So this confirms data is correctly stored inside the structure. Members are accessed properly. So, to conclude, the structures in C R play a very important role in writing efficient and organized programs. They allow us to combine different types of data into a single unit, which makes our code more meaningful and closer to real world applications. In real life scenarios, the data is rarely of a single type. For example, a student record includes name, roll number, marks, and grade, all of different data types. So the structures helps us to represent such complex data easily and logically. So another important advantage of structures is code clarity. Instead of managing multiple unrelated variables, we can group them under one structure, making the program easier to read, understand, and maintain. Structures also improve data management when working with large programs, especially in areas like student management system, employee databases, banking applications, inventory systems. So these structures becomes essential for handling grouped data efficiency. So as we move forward in C program, structures become the foundation for more advanced concepts such as arrays of structure, nested structure, pointers to structure, file handling, data structures like linked list, stacks, and queues. So understanding structures is not just important for exams, but also for building real world applications. So finally, we can say that structures helps us organize data, improve readability, and make our programs more powerful and scalable. So in this structure, we are also having some disadvantages. So it wastes the money. So the first one, wasted money. Compilers adds empty padding bytes for speed. Zero privacy. No private variables. Anyone can change the data. No methods. Cannot put functions inside the structure. Manual setup. No automatic constructors. Easy to forget the initialization. No inheritance, which means cannot easily reuse or extend existing structures. Slow passing, which means copying large structures to function, hurts performance. And the last one, no math operators. Cannot do struct A plus struct B directly. Thank you.